May June 2002, question number 7. A ball is projected from a point O with speed v meters per second at an angle of 30 degrees above the horizontal. At time t seconds after projection, the ball passes through the point A, whose horizontal and vertically upward displacements from O are 10 meters and 2 meters. Let's assume this as the horizontal ground. Now we have a ball which is projected at an angle of 30 degrees with the horizontal. So the angle of projection is 30 degrees. The motion of the ball will be something like this. And at t seconds, let's assume the ball is at this point, which will be point A. And at that point, the vertical displacement and the horizontal displacement of the ball are 2 meters and 10 meters. Let's see what the first part of the question says. By using the equation of trajectory or otherwise, find the value of v. You should be knowing from your lessons that the equation of trajectory of projectile motion is given by y, which is the vertical displacement, is equal to x, the horizontal displacement, multiplied by tan theta, where theta is the angle of projection, minus acceleration due to gravity into the horizontal displacement square upon 2 times the velocity square, initial velocity square, into cos square theta. We know that the vertical displacement y is 2 meters and the horizontal displacement x is 10 meters. So we can now substitute these values in this equation and find v. Let's do that. 2 is equal to 10 into tan 30 minus 10 into 10 square upon 2 into v square into cos 30 whole square. Simplifying this, 2 plus 10 cube upon 2v square cos 30 whole square is equal to 10 into tan 30. 10 cube upon 2v square cos 30 whole square is equal to 10 into tan 30 minus 2. 10 cube upon, bringing this whole thing here, 10 into tan 30 minus 2 is equal to 2v square cos 30 whole square. Making v the subject, 10 cube upon 10 into tan 30 minus 2. This whole thing divided by 2 cos 30 whole square under root will give you v. You should be getting v as 13.3 meters per second. This is the first part. Let's have a look at the second part. Find the value of t. When the ball passes through A, the time is t seconds, and we know the horizontal displacement at this point is 10 meters. You should be knowing this formula from your lessons, that horizontal displacement x is given by the speed of projection multiplied by cos of angle of projection multiplied by time at that point. At point A, the horizontal displacement is 10 and the initial velocity is 13.3 we have found from the first part, multiplied by cos 30 degrees, which is the angle of projection, into time. You should be getting time as 0.868. The third part of the question: find the angle that the direction of motion of ball at A makes with the horizontal. In order to solve the third part, we first need to find the horizontal component of velocity and the vertical component of velocity. And you should be knowing this from your lessons, that the horizontal component of velocity is given by initial velocity multiplied by cos of angle of projection. In our case, initial velocity is 13.3 and cos 30 is equal to 11.52. This is the horizontal component of velocity, and the vertical component of velocity is given by initial speed into sine angle of projection minus acceleration due to gravity into time at that point. We get this by 13.3 into sine 30 minus 10 into 0.868. We will be getting this as minus 2.03. To find the angle, we will be using tan theta is equal to Vy by Vx. Simplifying for theta, tan inverse minus 2.03 upon, you should be getting theta as minus 10.04. The minus sign just indicates that the direction of the ball is downwards and the angle it makes with the horizontal is something like this. So while giving out final answer, we should write that the angle that the direction of ball makes with the horizontal at point A is 10 degrees below the horizontal.